Now we'll be starting Chapter 2, Lesson 1, Place the First Digit, where we'll perform operations with multi-digit whole numbers and with decimals to hundredths. And we're focusing mostly on division at this point. Before we jump into the lesson, I'm going to talk about a couple key terms that you'll need to know. Before we look at what this means and what this looks like, I want to start with the basic math fact. 3 times 4 equals 12. 3 and 4 are both known as factors. So I'm going to write that pretty big. 3 and 4 are the factors. And when you multiply the factors 3 and 4, you'll get the product 12. The cool thing about multiplication is the inverse of multiplication is division. And what that means is if you take the product of a number, it becomes, which is the answer to a multiplication problem, it can become the dividend in a division problem. So the dividend is the total, what you're starting with. And so the dividend could be 12. And if you divide it by one of the factors, so either 3 or 4, which in a division problem is called the divisor, then you will get the quotient. And the cool part about the quotient, which is the answer to a division problem, is that it'll be the remaining factor. So if you do 12 divided by 4, it'll equal 3. If you do 12 divided by 3 equals 4. So you could see that in the multiplication problem, the two factors are your divisor and the quotient, which is what you're dividing by and the answer to the division problem. And the product is now your dividend. The reason why this is important is because I'm going to do number 1, even though they did it for us. We're going to start with number 1 before moving on to number 2. Is that when you look at one like this right here is the dividend, and that's the divisor. So before writing it inside of what I call the house sometimes, this one written left to right would be 388 divided by 4. The 388 is your dividend. The 4 is your divisor. And you're looking for the quotient. I like writing it left and right so that I can see the titles of it, dividend, divisor, and quotient. But when I actually divide this out using the standard algorithm, then I would write it like this, where the dividend goes inside of the house, 388, and the 4 goes outside. So the house kind of is just a straight line. You do not want to do something like this. This is square root, and so if you have a number inside of it, like 9, then the answer to this, it's not even a division problem at this point. It means it's the square root of a number. And you'll be learning about that more later, but whatever you do, don't make it look like a check mark here. It should be 2 straight lines. That being said, we're going to start doing 388 divided by 4. And for this one, we're going to use the standard algorithm. What was cool in the last chapter, if you look back at, I think it was either lesson 11, 12 or so, one of the higher lessons, not higher lessons, but the later lessons, we used multiplication to solve this, and we used specifically the distributive property. Here, we're going to still use multiplication, but in a different form. So, just like we made the cheat sheet in the last video, we're going to be using it. Since 4 is our divisor, we're going to be using the 4's here. And we're going to use multiplication to help us. Because keep in mind, this factor, or not factor, this divisor times the quotient, your answer is going to be written on top, should equal your dividend. So, let me say that again. The number outside, which is your divisor, if you multiply it by your answer, which will be written on top, which is your quotient, you should get your dividend, the number inside the house. Before we do this larger problem, let me show you what that looks like over here. 12 divided by 3 will look like 12, the dividend inside of the house. The dividend goes inside. The divisor goes outside. And if you say 3 times what number? 3 times 4 equals 12. And if you subtract it, you have no remainder, you have no leftovers. Then what you could say is 3 times 4 is 12. Or 12 divided by 3 is 4, or even 12 divided by 4 is 3. That's what we're going to be using to solve this one. We're going to start by saying 4 times what number is less than or equal to 3 without going over. We're going to ignore the other two numbers for a little bit. And we're just going to start with the first number closest to the left. 4 times what number gets close to or equal to 3 without going over. So let's look at our 4s here. 4 times 0 is 0. 4 times 1 is 4. 4 times 2 is 8, and so forth. We want to get close to 3 without going over. So if we look here, 4 times 0 is close to 3, does go over. And 4 times 1 is 4. 4 is too much. If we only have 3 of something, we cannot subtract 4 from it without getting a negative number. So 4 times 0 is 0. 4 times 0 equals 0. And that's what you're going to subtract. You're going to put the 4 times 0 here, put the answer here, and 3 minus 0 is 3. We couldn't use 1 because if we did 4 times 1 and we did 3 minus 4, if you have 3 and you try to take away 4, you're going to end up with a negative number. So you can't quote-unquote do it in that sense. Now we're going to bring down the next number. And we're going to look at the number 38. 4 times what number gets close to 38 without going over? If you do 4 times 0, that's not close to 38 at all. Let's try the next one. 4 times 1 is only 4. You have 38. You can do more. 4 times 2 is 8. Still, you could do more. 4 times 3 is 12. You have 38. You could do more. You want to get close to, you see these red answers? You want to get close to 38 without going over. 16 is close. 20, 24, 28. Ooh, now we're getting closer. 32, getting very close. 36, getting very close. And 40. So out of these answers, 32, 36, and 40, which one gets closest to 38 without going over? 32 is close, but 36 is even closer. 40 is too much. So we're going to use this math fact right here, because 32 is too small, 40 is too much, and 36 will work. 4 times 9 equals 36. So 4 times, the 9 will go here, equals 36, according to the chart, and that goes down here. 36 gets close to 38 without going over. 40 goes over, so we're going to use 4 times 9 equals 36. Now what we're going to do to these two numbers is subtract. 8 minus 6 is 2. 3 minus 3 is 0. Now we have 2 left over. We're going to bring down the 8. Before you bring down the 8, just know that this number should always be smaller than your divisor. So your remainder should always be smaller than your divisor, or else you did it wrong. This number could be higher. Now you're going to ask yourself, 4 times what number is closer or equal to 28 without going over? So you're going to look at your red answers, and you're going to look for something close to 28. 4 times what number is close to 28 without going over? You can see all of these ones are too little. Here we're getting close. 24 is close to 28 and doesn't go over. 28 is exactly 28, so that one looks like our answer. And 32 goes over. So if it's exactly the answer, that's perfect to use. 4 times 7 is 28. 4 times 7 is 28. And when we subtract, we have exactly 0, and that's fine. That means we have no remainder. We have no more numbers to bring down. So our quotient, here's where our divisor is. Here's our dividend. This top number is our answer. The top number is our quotient. And 097 is the same as 97. So 388 divided by 4 equals 97. Now to prove it, if you're to multiply the divisor by the quotient, you should get the dividend. So let's do that on the side to double check our work. If we do 97 times 4, let's see if we get 388. 7 times 4, or 4 times 7, is 28. 4 times 9 is 36 plus 2, 37, 38. And you could see here, 4 times 97 equals 388. So 388 divided by 4 equals 97. And our final answer is 97. What I want you to do is I do want you to label all of this out. And you can see that they're not asking that for the directions here, but I do want you to do it. Mostly because it helps you become better at using the mathematical terms, as well as it gives you a sense of, why these numbers work. The other thing I want you to notice before we move on is a little bit of math sense. If you think about this, you have 388 cookies, or you have $388. Let's say $388. Let's turn this into a thought process for a sec. If I were to turn this into a word problem using these numbers, I could say I have $388 total. Now I'm going to divide it up amongst 4 people. I'm going to share it with 4 people. Think about the $97. What that means is each person, if I were to divide it equally and no one has any extra, no one has any less, each person is going to get exactly $97. Let's see why one doesn't work. Think about if I had 3 $100 bills. 1, 2, 3. If I have 3 $100 bills, can every person get 1 if I'm dividing it with 4 people without anyone getting upset? No, because I could give 1 to myself, 1 to my first sister, 1 to my second sister, and when it comes to my last sister, I ran out of money. So everyone's going to get less than $100. No one can get $100 each because there's not enough to share it with 4 people. If you only have 3 $100 bills, you can't share it amongst 4 people. You're going to have to take that $100 bill, you're going to have to go to the bank, and then break them into tens. So you have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, over and over again. And now you'll have 10, 20, 30, that's where this 3 comes from, 30 tens, and then you still have your 8 tens from before. And so what they're saying is now you have all of these tens plus these 8 tens, and you're realizing everyone can get 9 tens, and then when you continue doing the math, 7 ones. So everyone's going to have less than $100, because if you have $388 and you only have 3 hundreds, no one can get a full 100 if you're sharing it with 1, 2, 3, 4 people. So everyone's going to have less than 100. They are actually going to get only $97. All right, I kind of threw a lot of information trying to explain other things near the end. The most important focus is that you understand this process and how you can use multiplication to show your work, to double check your work, to check your answer. If you don't quite understand all of this, I'll explain it again in the next problem. But with the next problem, what I do want you to do on the top here is label the dividend and the divisor. So your dividend divided by your divisor equals your quotient. So your dividend for number 2 is 457 divided by 4, and then that'll equal your quotient. And so if you're to rewrite this, and I don't want you using theirs. They type this up so small, even when they're rewriting it, it's bigger. What I want you to do is write it nice and big. And make sure that all your numbers are nice and neat, because in division, neatness counts. All right, let's do this again. We're using multiplication because your divisor multiplied by your answer, your quotient, should equal your dividend. So you're going to use your 4s chart again. They really like their 4s. And you're going to say 4 times what number gets close to or equal to 4 without going over. So you can see how I'm looking at the first number right here, just the 4. So 4 times what number? You're looking at the reds, is 4 or less. So 4 times 2 is 8. That's too much. So we're not going to do 4 times 2. But the cool part is we have a 1 here. 4 times 1 is exactly 4, and that's the one we're going to use. 4 times 1 equals 4. And then we're going to subtract these two numbers. 4 minus 4 is 0. We're going to bring down the 5. Now we're going to ask ourselves, 4 times what number gets close to or equal to 5 without going over? So again, you're going to look at the 4s, and you're going to look at the reds. And you're going to think, all right, this section is way too big for the 5, so we're going to look somewhere here. 4 times 2 is 8. You only have 5, so you can't use that. We're going to again use the math back. 4 times 1 equals 4. So 4 times 1 equals 4. And when you subtract, 5 minus 4 equals 1, 0 minus 0 equals 0. When you get to this step, you're going to bring down the 7. And you can see that I draw an arrow. The reason why I draw the arrow is because now I know I've already used the 4 and the 5. And so make sure to draw this arrow so you don't forget, and that way you can keep track of what you're doing. You can see that the arrow stops right at the subtract or the equal sign that I just used. So the 5, I stopped it right here. The 7, I stopped it right here. But I give it enough room where I could draw the 7 right next to the number before it. You're dropping down that same number. And you're asking yourself, 4 times what number gets close to or equal to 17 without going over? So you're looking at your reds here. We're looking at the 4s because it says 4 is your divisor. And we're looking at the reds for a number close to or equal to 17. You can see these reds are way too big for 17. These ones are too small. So we're going to look somewhere in this section. 12 is a little small. 16 is still a little small. But 20 is too much. So if we were to do 4 times 5 equals 20, that's too much because we only have 17. So we're going to use 4 times 4 equals 16. 4 times 4 equals 16. And when we subtract, we have 7 minus 6 is 1. 1 minus 1 is nothing. And you can see that we have no more numbers to bring down. So at this point, this 1 is our remainder. So we're going to write a small r and then put that remainder, our leftover, right here. And so our final answer for this is 114 remainder 1. Now, just like we did before, I do want you to use multiplication to double check your answer. So you're going to ask yourself, but Ms. Saltina, how do we check our answer with multiplication if we have a remainder? So what we're going to do is we're going to multiply still the divisor by the quotient. We're only going to look at the 114. We're going to ignore the remainder for now. So let's first just do 114 times 4. 4 times 4 is 16. Oops, if you don't know, you could look at your cheat sheet. Right, yeah, in the cheat sheet. 4 times 4 is 16. Regroup the 1. 4 times 1 is 4, plus 1 is 5. 4 times 1 is 4. So far we have 456, and you can say, Ms. Tolentino, the two numbers don't match. The product right now is 456, and the dividend right now is 457. But don't forget about that remainder. That remainder 1 is something you're going to add when you're done multiplying. So we're going to add the remainder, and you'll see that you have 457. And now, after we multiplied and added, we multiplied the divisor and the quotient, and we added the remainder. Now you can see that they match up. So 457 is equal to 457. As you can see, I'm writing nice and neat, and I'm showing all of my work, and this is not enough space for me. So what I'd highly recommend is to use your math journals so that you could show all of your work. I do want it to look like, where's my work here? I do want you to label your dividend, divisor, and your quotient, both left and right, as well as solving it. And then I do want you to multiply it out. So you could see I wrote the dividend, divisor, and quotient. I wrote it left and right as well as the standard algorithm, and then afterwards I multiplied it. The cool thing about here is you could see, like imagine you have $457 and you're sharing it with 4 friends again. Each person does get $100 bill. They get one of the tens, then they had to break up the tens, and then they get 4 ones after that. I hope that this is making a little bit more sense. I don't think I'm doing my best job explaining as I have in previous actual live demos, but I think that's because I feed off your energy when I do this one live, and this one's a little bit more dry. Let's do one more problem before we start doing the word problems, and that is just setting this up. The cool thing is they gave us the dividend and the divisor left and right already, so you could just go ahead and label it on top. Dividend, divisor. And we know that the dividend goes inside, so it goes 2,117 divided by 3. So this is the first number and it goes inside the dividend, and then there's the divisor. And I'm not going to solve this whole thing for you, but I do want you to know that you're going to be looking at the 3's. And you're going to ask yourself about the first number only. Cover everything else up. 3 times what number gets close to or equal to 2 without going over? And when you look, these ones are definitely way too high. So if you look at the 3's, these 3 look closest. 6 is too much. 3 is too much. So you're going to have to use the math fact 3 times 0 equals 0. And so you're going to say 3 times 0 equals 0. And then you're going to bring down the 1. Okay, and then you're going to continue. 3 times what number gets close to 21 without going over, and then bring down the next number and so forth. So hopefully that's a good setup to start you off. Don't forget when you're done with this, you check it using multiplication. And I think my next video might do a little bit better because I'll tell you that the topic is virtually the same thing, but hopefully I do a little bit better. That being said, let's move on to the word problems. Keep in mind that with the word problems, this will definitely not be enough space, so you have to do it in your math journals or on a separate piece of paper. The school theater department, theater is someone that kind of puts on plays and shows. They made $2,142 on ticket sales for 3 nights of their play. The department sold the same number of tickets each night, and each ticket cost $7. How many tickets did the theater sell each night? Ooh, there's quite a few numbers being thrown up here. So, the school theater department made 2,142 tickets on ticket sales for 3 nights of their play. The department sold the same number of tickets each night, and each ticket cost $7. How many tickets? So we want to know the amount of tickets did the theater department sell each night. Just by looking at this, just because I can see the pattern already, I know that there's not pattern, but reading through it, I know that this is going to be a 2-stepper. And if you don't realize that this is a 2-stepper, you're going to have to reread it and think, okay, what do I need to solve? There's quite a few things, especially because they're asking each night. So I'm going to start with $2,142 because that is our total, and the total always goes on top. But the 2,142, and it's not good enough just to say total, is the total sales for 3 nights. If you do not write the total sales for 3 nights, you might get confused. Now, the first thing you need to do is know that they want to know the amount of tickets for 1 night, for each night. So, let's say that this is night 1, night 2, and night 3. The first thing you need to do is figure out how much they made each night. How much money did they make each night? So, you're going to take the total sales for 3 nights and divide it by 3 to find out how much money. The X is the total money, or the amount of money raised each night, made each night. because we want to know how many tickets were in each night. So the first thing we're going to do is 2,142 divided by 3. This looks very similar to all the stuff that you've been doing on top. Now, once you get this answer, you're not done yet. Once you get that answer, you just found how much they made night 1. They're asking for how many tickets did they sell each night. So once you get that answer, you're going to have to do a second picture. So I'm going to draw the second picture up here because I'm running out of space. But what you're going to do is you're going to take that answer, this circled answer, and that is the total money made in one night. And what you're going to do is you're going to figure out how many tickets they sold each night. But we know that one ticket, this is ticket 1, cost $7. We know that ticket 2 cost $7. We know that this ticket cost $7. The problem is we don't know, question mark, how many tickets there are. So the second step, because I told you this is a two-stepper, is you're going to take the amount of money that they made in one night and divide it by 7. So whatever this answer is, your quotient here, will become your new dividend. And you'll put it right inside here and do 7 divided by what? Whatever that was. I hope that that kind of makes sense. If not, reread through this again, look through the pictures, but we'll solve it when we get to class if you haven't made it all the way. Whew. Go ahead and have fun finishing that one up. If you want, you could pause, but I'm going to start reading number 10. Andreas made $625 mowing yards. Yards meaning not like a distance of something, but like, like the backyard, the lawns and stuff. He worked for 5 consecutive days and earned the same amount of money each day. How much money did Andreas earn per day? The cool thing about this one is this is going to be a one-stepper. And I could tell because when I start drawing it out, I guess. So, Andreas made $625 mowing yards, and that's the total amount. So this is $625 is the total made for 5 days. He worked for 5 consecutive days and earned the same amount of money each day. How much money did he earn per day? So this is like saying day 1. The next box is day 2. The next box is day 3. The next box is day 4. The last box is day 5. So the total that he makes goes on top, and we know that's 625 total dollars made for 5 days, and each box represents a day. The first day, the second, the third, the fourth, the fifth. Consecutive just means it's like Monday, Tuesday, Wednesday, Thursday, Friday. Like he didn't miss one day. If it was non-consecutive, then maybe he worked on Saturday, and then he took a break on Sunday. Then he worked again on Monday. Then he took a break. Then he worked on Tuesday. So non-consecutive means that, he might have taken some breaks. But consecutive means Monday, Tuesday, Wednesday, Thursday, Friday, or Sunday, Monday, Tuesday, Wednesday, Thursday, or Saturday, Sunday, Monday, Tuesday, Wednesday. It means he didn't stop. Now the thing is, you don't know how much he made on day 1, so that goes X. You don't know how much he made on day 2, but it's the same amount, so it's going to be the same letter. You don't know how much he made on day 3, so it's the same amount, same letter, same letter, same letter. And the X represents the amount of money in one day. Based on this picture, you have a total, and you're getting smaller. And you're repeating the same number. So what you're going to do is 625 divided by 5. The 625 total amount divided by the 5 consecutive days. Okay, I hope that this helped. I know that I talked a little bit fast. I'm hoping that I'm going to do 2-2 a little bit better, especially because the topic is virtually the same. And I'll probably be feeding off of your energy after having taught it. Ooh, sometimes I don't love YouTube videos because I can't gauge your reactions and things like that, but let me know if things are unclear. All right, have a good day.